Today's vehicles have higher engine outputs, travel at higher average speeds, coupled with increasing stop-start motoring, imposing an even heavier load on the vehicle's hard-working cooling system. Each time ignition takes place in the combustion chamber, a tremendous amount of heat is generated by the combustion gases. This heat is transferred to the pistons and surrounding components. The cooling system absorbs and dissipates the heat, thereby allowing the engine to operate at optimum efficiency. An intense amount of cooling is required to avoid thermal overload and consequential damage. How is this achieved? Coolant, driven by the water pump, flows through the spaces surrounding the cylinders and combustion chambers, carrying away a portion of the waste heat produced by the combustion gases. Initially, coolant circulation is restricted by the thermostat to the passages into the engine water jacket. This permits fast, even engine warm-up. Once the engine warms to its efficient operating temperature, the thermostat opens, allowing the heated coolant to flow through the radiator. Here, heat from the coolant is conducted through the thin walls to the fins of the radiator to be carried away by the outside air. Now cooled, the coolant flows back through the engine and the cycle is repeated. Let's have a brief look at the function of each component in the cooling system. The radiator cap covers and seals the filler opening and controls cooling system pressure and vacuum. The radiator dissipates excess heat and acts as a coolant reservoir. The fan forces air through the radiator core. This forced air is required mainly when the vehicle is stationary or in stop-start traffic conditions. The water pump circulates coolant through the radiator and engine. The thermostat prevents coolant flow through the radiator until the coolant reaches engine operating temperature. The hoses carry pressurized coolant to and from the radiator, also act as shock absorbers between the engine and radiator. And finally, the fan belt drives the water pump. Since 60% of vehicle breakdowns are caused by overheating, we need to take a closer look at some of the probable causes. The most common cause of overheating is simply a lack of sufficient coolant. It's advisable to check coolant level only when the coolant is at ambient temperature, with the engine switched off. The correct coolant level should be 10 to 15 millimeters under the bottom of the filler neck to allow for coolant expansion. Coolant loss can be caused by either internal or external leaks. External leaks can usually be detected by a thorough visual inspection. Leaks can occur at head gaskets, hose connections, radiator cores, radiator caps, and cylinder block drain plugs. Internal leaks may be due to loose or cracked cylinder heads, damaged gaskets, or a number of other items. Internal leaks can result in serious damage. They not only cause coolant loss, but also allow intermixing of the coolant and engine oil. A cooling system needs to be pressurized in order to increase its boiling point. But a leaking radiator cap allows loss of pressure and coolant. For a simple check of the cooling system pressure, remove the radiator cap. Install a pressure tester in the radiator top tank and pressurize the system. If the pressure isn't maintained, it is advisable to consult your cooling system specialist. Carefully inspect the radiator cap, seals, and sealing surfaces. A damaged pressure cap seal will prevent the cooling system from building up pressure. Also check the top tank filler neck surface for damage. As the coolant temperature rises, the coolant expands and pressure increases. The valve opens, allowing excessive coolant and pressurized air to flow out through the overflow. This prevents excessive pressure in the system. When the coolant contracts, a vacuum condition results, and to compensate, the relief valve opens. In a closed system, the coolant from the header tank will flow back into the radiator. Another valve that needs checking is the thermostat. This valve prevents coolant flowing through the radiator until the coolant reaches operating temperature. If the valve sticks in the shut position, the engine will overheat. If it sticks in the open position or opens too soon, overcooling may result. Engine warm-up takes longer and leads to excessive engine wear. Therefore, never operate an engine without a thermostat. The opening temperature is stamped on the top. Even if this valve is functioning correctly, incomplete or improper filling can cause problems by allowing air in the cooling system. Air in the system produces foaming or aeration. The air bubbles insulate various parts of the engine from the coolant, and hot spots form, creating steam. The system becomes pressurized, and coolant is discharged through the overflow. Exhaust gas leakage into the system causes similar conditions. Exhaust gas can enter through internal cracks of a defective cylinder head gasket. We have considered the problems of insufficient coolant, but what of the coolant itself? The coolant is a very basic but necessary part of every cooling system. Always use clean water and a suitable inhibitor. Chemical reactions resulting from unsuitable water can cause extensive cooling system damage and possible mechanical failure. One sure way to drastically reduce this degradation is by using an inhibitor, such as Radcare, which not only protects your system from rust, but also prevents chemical deposits. In addition, Radcare raises the boiling point of the water and lowers its freezing point. Another important link in the cooling system is the fan belt. If fan belts are too loose, they vibrate enough to cause unnecessary wear on the belts and pulleys, and possibly slip enough to cause overheating. If the belts are too tight, unnecessary stresses are placed on the fan belts as well as the water pump bearings. Fan shrouding increases fan efficiency by controlling and directing airflow through the radiator. But despite effective shrouding, reduced airflow can still occur due to the accumulation of foreign material, clogging the radiator core's air passages. Another common cause of airflow restriction is damaged or bent cooling fins. This usually results from objects striking the fins during travel. Many times, suspected overheating can be traced to a defective temperature gauge. This usually occurs when the gauge indicates red, but no coolant is lost. Engine overcooling can be as harmful to the engine as overheating, and exists when normal operating temperature cannot be reached. This is usually caused by coolant flow past the regulator directly into the radiator top tank. A thermostat stuck in the open position or opening too soon are common causes of overcooling. After checking the thermostat, thoroughly inspect the thermostat housing. Be sure sealing surfaces are clean, smooth, and free of foreign material. Always fit a new gasket after thermostat inspection or replacement. As cooling system efficiency is directly related to the vehicle's engine's life expectancy, its efficiency, and downtime, it is therefore of paramount importance that regular cooling system inspection and maintenance be carried out. As radiator hoses form a vital link in the cooling system, check for cracking, bulging, sponginess, and bursts. Fan belts are another important and often neglected part of the system. Visual inspection can be carried out by simply turning the belt over with your fingers and looking for glazed sidewalks caused by oil, aging, or slippage, cracks from high temperature operation, missing teeth, and uneven wear caused by misaligned pulleys or pulley wobble. Effective maintenance means saying no to downtime and saying yes to a longer engine life and increased profits. Silverton, your cooling system specialist, offers fleet cooling system surveys as well as testing and technical advice. All this free of charge. For further details, contact your nearest Silverton service specialist. There's one near you.
Well laid out and tidy workshop promotes a quality image and encourages quality workmanship. Let's start with the basic equipment. Here we have nozzles and a blowtorch. For radiator repair work, we use nozzle sizes number 1 and number 2. Successful radiator repair work largely depends on the correct setting of the torch flame. Adjust the torch to give a sharp pencil-like flame. This setting gives the hottest and most concentrated flame. Never use a nozzle larger than a number 2. A large torch flame causes overheating and damage, resulting in tube-to-header plate leaks. If the core is to be reused, it will be necessary to re-sweat the header plate. The only time you may need a broader spread flame is for stripping down old radiators. This is a flame economizer, a device which cuts off the gas when the torch is not being used. Let's move on to the next useful piece of equipment, the radiator stand. The radiator core is held firmly in position and can easily be moved to any desired position. Check that these rubber pads are fitted. They protect the radiator. Here we have flux readily available. This container should be cleaned and refilled regularly. Contamination of the flux caused by paint and dirt can be transferred by the flux brush onto a soldered joint, resulting in a poorly soldered joint. For a good soldered joint, a good quality flux is a vital ingredient. Never try to make your own. Use only red flux, which has been specially formulated for the job. And now, for the flux brush. Wasted flux causes extensive damage to equipment and workshop floors. How can we prevent this? Simple. Use only the correct size flux brush. Throw out these large brushes from your workshop. Now let's move on. Before you place a dirty radiator into a cleaning tank, first wash it off under pressure using a detergent. This will lengthen the life of your tank's cleaning chemicals. Now place it in the heated cleaning tank. The tank should be of a reasonable size and heated to about 85 degrees Celsius. It should be treated with a good quality alkaline cleaner. But remember, after continuous use, the alkaline cleaner loses its effectiveness. This test kit can determine how much cleaner needs to be added. Use a cleaner such as Red Clean. Red Clean is an effective cleaner. It is less corrosive to the building and the fumes are less harmful to the operator's health. Caustic soda may be cheaper, but is far more damaging and, in the long term, far more expensive. Next up is the test tank. For best results, fill the tank with clean water. Add a suitable additive such as this penetrance powder, which will illuminate the bubbles, especially if the tank is painted white or light blue. The tank should be heated to about 70 degrees Celsius. And now for the test equipment. First, we need a good quality gauge with a full scale reading from 0 to 250 kPa. Also needed is an on and off valve and a regulator so that the test pressures can be accurately set. In addition, you need a range of test plugs to fit the various sizes of inlet and outlet pipes. Finally, you need a range of pressure test caps with snap lock unions to match the connector at the end of the air line. You can now introduce the correct pressure into the radiator, leaving both hands free to adjust the test pressures to different levels while checking for leaks. We can also check for cooling system leaks without removing the radiator by using this pressure test gauge and pump. Pump to a pressure of 100 kPa. A loss of pressure on the gauge will indicate that there is a leak in the system. Pressure caps can be tested in a similar manner. This is a block tester used to check for the presence of carbon monoxide. If the fluid changes color from blue to yellow, it is an indication that there is combustion gas entering the cooling system, which may be the reason for the vehicle overheating. Various causes for gas leaking include a cylinder head gasket crack or leak, or even a faulty O-ring on a wet cylinder sleeve, etc., etc. Let's move back to the workshop. In addition to the basic range of equipment, a workshop should be equipped with a compressor, a spray booth, and a spray gun. While spraying, the operator should wear a mask for protection against harmful fumes. Other essential equipment needed is a steam cleaner or high pressure washer. That covers the basic equipment. Now let's look at our first job. Here we have a damaged core. To repair it or to recall it is the single most important decision. Your most experienced person should make this decision. This training manual will give you some additional guidance, but experience will be your best guide. In this case, we have decided to recall. Before stripping the radiator, one should indicate the position of tanks, fittings, and side frames on the back of the job card, or else mark the actual positions on the tank. Now to strip the radiator. This should be done over a dross tray filled with clean water. This ensures that solder drops to the bottom and any flakes of paint or dirt float to the top, so that at the end of each day you can scrape off the dirt and you have a good clean solder dross. Also notice that there is no need to use a big torch flame. A nice pencil-like flame, giving a hot concentrated flame, will quickly melt off the old tanks and side frames. While the tank is hot, use a wire brush to brush off all the old paint and dirt to get the tank as clean as possible. Now for the next step, to brush the lip of the tank. Brush both the inside lip as well as the outside lip. Both lips must be thoroughly cleaned. Before we go to re-sweating these tanks on a new core, let's look at the correct procedure and sequence for soldering tanks to header plates. Firstly, position the tank correctly. Make sure that there is a good tight fit between the tank and header plate. Spot solder the tank into position at one end. Keep pressing down until the joint becomes solid. That's one end soldered into position. Now for the other. Flux with a small flux brush and use a minimum amount of heat and solder. Applying excessive heat at one spot will cause tube to header plate leaks. Here you see the operator with the core angled to the correct position, that is, at about 45 degrees towards the operator. When you solder with the core in this angled position, you get a nice fillet between both the outer head of the tank and the header plate, as well as between the inner lip of the tank and the header plate. The joint will be 4 times stronger when compared to a joint soldered with the core placed vertically. Okay, so let's recap. Soldering with the radiator correctly tilted will save solder, will give a stronger joint, and will ensure that tube blockage will be minimized. And now let's follow the correct soldering sequence. Solder along this line from this side to this side. Turn the core around and then solder along the other side of the tank and header plate. Notice again the small flux brush. Notice the pencil-like flame, and notice how he is running the solder only along the bottom lip of the tank so that the solder runs down into the joint. Finally, finish off the ends. Another important point, you will notice that when using this correct sequence, there is no need to use flux or water to cool down the joint. To obtain the strongest joint, solder should be allowed to cool naturally. Quick cooling of solder using flux or water results in a brittle joint, one which can easily crack and, at a later stage, leak. Note that before we start a repair, we should visually inspect the core for damage and the tubes for blockages. This particular radiator repair has a large overhang. To eliminate the risk of it dropping at the center, we first of all spot it in position in the center of the tank. Ensure that it is very centrally seated up against the header plate. Now you see him soldering the bottom tank into position. Again with the core correctly tilted. Again doing it in the correct sequence to ensure that the header plate is not being overheated in any particular part. The torch should be pointed at the tank and not the header plate. And now for a useful tip. To avoid wasting solder ends, with just a little touch of flux and a gentle touch with a blowtorch, pick up an old strip of solder so there is absolutely no solder wastage. And remember, a professional operator does not waste. Now for our next job, a header plate leak. This is a reasonably new radiator. It doesn't need a re-core. After thorough cleaning, the radiator is put in the test tank to see exactly where the leak is occurring. Again, on a leaking tube to header plate, we should be sure that we remove the tank and should ideally re-sweat all the tube to header plate joints. Motor vehicle radiator manufacturers use solder with very low tin content, which means after 3 or 4 years in service, the solder on the radiator can lose its strength and a tube to header plate leak can occur. This may show up first at only one end of the core. It can be only the start. Tube to header plate leaks will soon start leaking at other places as well. So, unless a really low-cost job is requested, we should re-sweat all the tube to header plate joints. Okay, let's move on. Here you see an operator repairing one end of the core. He is cleaning the end of the header plate using flame and wire brush. While the core and header plate are still hot, dip them into the acid tray for about 2 minutes. Note, this is the only part of the repair where acid is used. Next, flush off with clean water. We now have a really clean surface to start working on. Again, the very short, sharp, pencil-like flame going along each side of the tube joint, and then the process is reversed, going along the other side. Use a small flux brush. Note, no flux is being thrown all over the radiator, the floor, or the equipment. And remember, a professional operator is a clean worker. There is a correct sequence for re-sweating tube to header plate joints. Let's take a closer look at the sequence. Go along each side of the tube, along side lines 1, 2, 3, 4, 5, and having been right along the header plate, we should turn the radiator and repeat the sequence along lines 6, 7, 8, 9, 10, and so on. When going along the outer edges, avoid any solder running into the lip of the header plate, as this will make it difficult to get a secure joint between the tank and the header plate. Now let's move on to another common repair, a tube leak in the middle of the core. To do this job properly, we should really take off both top and bottom tank. Find out which tube or tubes are leaking and block these off with solder, both top and bottom. However, sometimes a low-cost agent repair is needed, which requires repairing the leak externally. Let's see how this should be done. The art of doing this repair is to accurately identify where the leak is. If we don't identify the leak correctly first time, we can end up by burning away more of the core than we are repairing. Once the leak has been found, very carefully move the fins apart. Use a number 1 nozzle, a small amount of flux, and apply a minimum amount of heat. Very carefully tin over the area of the leak, slowly building up the solder in stages using solder paste. When the repair is finished, carefully bend the fins back into position, leaving a very neat and tidy job. Now we come to the most important part of a radiator workshop program, the test program, checking the quality of the workmanship. First, we need to fit the correct size of test plugs. Next, we fit the correct test cap using the snap lock connector. These pressure caps have a rubber which seals off the overflow pipe. Ensure the regulator is closed and the on and off valve is in the off position. Gradually, with the air valve on, turn up the regulator to a pressure of 35 kPa and fully immerse the radiator in the test tank. If there are no leaks at 35 kPa, turn the regulator to increase the test pressure to 75 kPa. Again, checking the radiator, turning it over both sides to check for any possible leaks. If still no leaks occur at 75 kPa, increase the test pressure up to 120 kPa on the third and final check. Always work through the range of test pressures. Leaks can occur at one pressure which will not be seen at another test pressure. If just a single high test pressure is used, this can either blow up the tubes in the radiator or seal small leaks which would have been easily seen at the lower test pressures. Now, let's look at finishing off the radiator. Here you see the operator polishing the inlet pipe as well as the outlet pipe. Next, mask the pipes with masking tape. Here we have a more economical way of doing it to prevent spraying over the inlet and outlet pipes. An old cap can also be used to mask off the filler neck. Ensure that the radiator has been washed to remove flux and other chemicals. And now to the spray booth. Here we see a simple radiator spray stand. The radiator can easily be rotated to any desired position. Spraying a radiator requires a particular technique. Spray from each of 4 different angles by rotating the radiator through 90 degrees. Ensure that there is a thin, evenly spread coat of paint over the entire radiator. Note the operator's safety mask. Having completed one side, turn the radiator over and spray in exactly the same way. Don't overspray on the core, as this will reduce the cooling efficiency of the radiator. Use specially formulated red part paint for a nice semi-gloss finish. After allowing a few minutes for the paint to dry, remove the old pressure cap and the masking tape or the newspaper. The inlet and outlet pipes as well as the filler neck should be in their original brass polished condition. This makes it easier for the mechanic when refitting the radiator to the vehicle. At the customer's request, a new pressure cap of correct pressure setting can be fitted. Finally, fit a new piece of overflow pipe if applicable. This is the finished product, a professional recall carried out with pride and expertise, a product which can be guaranteed with confidence. The Silverton guarantee label placed on the radiator before spraying should have a unique serial number, and this should be cross-referenced to your job card so that you can identify any job in the workshop, and in case of any comebacks, you can identify which operator did the job. Right, so far we have dealt with the traditional copper brass radiators. This is an aluminum plastic tank radiator. In South Africa, more than 40% of the cars are fitted with plastic tank radiators as original equipment. Let's see how the operator removes the plastic tank. It's a simple operation. While the tank is held firmly in position, just open up castellations around the header plate using de-clinching pliers, like this. Once all the castellations have been opened, simply remove the plastic tank. Plastic tanks are often damaged by mechanics using screwdrivers to remove hose clamps and hammers to remove stuck filler caps. As a radiator wholesalers, supply replacement tanks for all locally produced plastic tank radiators. For repairing tank damage on imported cars, SA Radiator wholesalers provide special epoxy resin called mastonite. If the plastic tank has to be reused, ensure that the sides of the tank are absolutely parallel. In many cases, the leaks are caused by contraction of the plastic. Note how the rim of the plastic tank is curved inwards. There is no point in trying to recore a radiator using this old plastic tank. If the tank is to be reused, then our first exercise must be to restore the plastic tank into its true condition. This is done quite simply by making wooden wedges to expand the sides of the tank into its correct position. The tank is placed into boiling water for about 20 minutes and then immediately immersed into cold water. Remove the wooden wedges and you will see that the tank sides have come back into their true position. This procedure may have to be repeated. Next, the operator is checking that there are no blobs of solder and that the rim of the header plate is absolutely clean. This is a replacement copper brass core which comes complete with replacement gaskets. These gaskets are specially molded. Use only the correct replacement molded gaskets where available. To lubricate the gasket, use washing up liquid. This will assist in properly positioning the gasket between the tank and header plate. Now, place the tank on top of the gasket. Compress the tank onto the header plate. Do not apply excessive pressure, as this can crack the plastic tank. And now, start bending over the castellations. Here we see a broken inlet pipe. The operator will first of all use a broken hacksaw blade to cut off the broken section and then to roughen up the surface of the plastic both inside and outside. This brass collar has been made to fit tightly inside the broken inlet pipe. Make sure that the surface is roughened up. Now, mix up some mastonite with 1 part epoxy resin and 1 part hardener. Apply the mixture evenly. Only a small amount is needed. Spread the mixed mastonite evenly over the outer edge of the brass collar and the inside of the broken inlet pipe. While the mixture is still wet, push the brass collar into position inside the broken inlet pipe. Now fill in the cracked part of the inlet pipe with epoxy resin. It should be overfilled so that once dry, it can be filed down into a smooth contour. Now, spray over the repair end. Now look at this. Can you tell that there was a break? Broken filler necks can be repaired in the same way. Broken overflow pipes can be repaired in a similar manner. Sew off and file down the overflow pipe. Drill out the hole in the tank using a 5.5 mm drill bit. Cut a thread by screwing in the fitting. Remove the fitting. Now smear the mixed mastonite on the thread of the replacement brass overflow union. Next, insert the union into the hole and screw down until tight. Make sure that the hole is clear. Even cracks in the tank can be repaired by putting a patch cut from an old tank on the inside of the tank. To assist you further on your road to becoming a Silverton professional, these special workshop manuals provide full details of the techniques mentioned in this video for repairing and recoring radiators. We have now covered the basics in equipment and workshop practices. But hold on, there's more. As a radiator wholesalers provide a comprehensive range of top-class products and replacement units to assist you to carry out a professional repair or recore. Get it right first time and become a Silverton repair specialist. And now it's up to you. Silverton, the motorist's first choice for over 40 years. Silverton, where quality comes as standard.
like to demonstrate our AccuRod with flux. This particular rod has a 30,000 psi tensile strength, and its working temperature right around 600 degrees Fahrenheit. So this particular rod, you're going to be working on your light-duty metals similar to evaporators, condensers, even charged air cooler cores themselves. This particular repair here, just imagine, if you will, that this elbow here is damaged. What we're going to do is we're going to pull this elbow out. When we're heating, we're going to make sure you're heating both joints at the same time. Distribute your heat evenly. When that aluminum just starts to bead up, you'll see it right there, it's starting to bead. You want to get ready to pull that out of there. Now, as with any soldering or aluminum brazing process, you want to make sure your surfaces are very clean. Now, if that elbow was damaged, what we would do is take one off of another condenser and install that. That back in place. Then we want to grab some of our wonderful rod. This particular rod with the flux combination has very good flowing properties. You're going to run it just about like solder. And what we're going to do is just heat the rod up a bit and stick that right into the flux powder. You'll see it will hang on. You just want to apply your flux liberally to your areas that need to be brazed in place. And then just like we took the elbow out, you want to get your heat distributed evenly, using plenty of flux to help the rod flow out. And this rod, the flowing properties are tremendous. You can see how that just sucks right around that elbow. Again, with condenser repair, on this particular condenser, down here you can see where something had hit the condenser and actually poked a hole in the tube. Over here, you'll see where I actually cut a section out of the condenser. We would do this in this particular case rather than throwing the whole condenser out. We cut a section out of the condenser, and we're going to place a larger tube over top the actual tube itself that connects the elbows at each end. And again, with the AccuRod with flux, makes this repair very, very easy to do. Going to heat your rod up again, dip it into your flux, capture some of the flux on the end of the rod. Using ample flux, keeping your heat moving, we're waiting for the flux to liquefy and pull down into your seam that you want to bond together. And we're waiting for this flux to change the aluminum to an almost shiny color, which is just right about there. And at that point, we're close to our 600-degree working temperature. We'll just start adding just a little bit of rod to it. You'll see that it actually starts to flow. This stuff, using your bench torch, which this particular one is bottle gas, LP gas, your natural gases will work. You can use oxyacetylene, but you're working with a much hotter flame. You may not be able to control the flowing properties as well. Do this again. With the 30,000 PSI tensile strength, this condenser won't have any problem holding up to them kind of pressures. I'm waiting for that flux to change that metal right about there. And with your 600-degree working temperature, you can see how that flows out. I'll try and liquefy this and get a good temperature reading for you. Just about 600 degrees. Okay, our next repair for our AccuRod with flux is going to be on a GM hose assembly. Just imagine, if you will, that the hose was rotted on this car. We took the hose assembly off and cut the rubber parts off. This here being the end to the compressor. We're going to attach an aluminum barb back to this, making sure all your parts are cleaned. I like a stainless steel round brush for cleaning these up. Make sure everything's joined together. Same as with our last couple repairs. Now this metal is a little bit heavier. It's going to take a little bit longer for us to heat it up. We're just going to use ample supply of our flux. Make sure we have a good sound change. Keeping most of the heat on the thickest part. We're waiting for that flux to make our color change. As soon as our color change starts to appear, we're going to test our rod. See how well that flows around there. Look at that. That's just about as good as it came from factory. Our next repair is going to be on an aluminum radiator. This just happened to be a GM radiator. I'm going to show how to block off a tube on the inside, on the water side of the radiator. You can work on the core side of the radiator. There's also an Accutech epoxy repair for that. If this particular repair here, we're just going to block this off right on the very end tube. You want to make sure, I use a stainless steel wire brush for cleaning. Make sure it's very, very clean. And with all the AccuFlux repairs, you're going to want to heat the rod and get a little bit of flux on the end of that rod. Apply your heat in an even manner. The repair you want to do, melt some of the flux onto your repair. And again, what we're looking for is the color change. And at that color change, your metal is almost at your 600-degree working temperature. Notice right along the top of the tube, it's starting to get that almost shiny color. And at that point, you're going to want to add your rod. The flowing properties for this rod is absolutely tremendous. For 100% leak-free seal every time. When this does cool down, you can take your damp rag and just wipe that flux right off. I'd like to debut our new rod on this video. This rod is good for aluminum, but one of the most unique characteristics to this rod, it's for putting bi-level, bi-metal parts together. You can see that this is a brass nut with a aluminum barb. You'll see this application on a lot of different condensers that are out, your Volkswagens and your Audis. One of the most unique things about this rod, it is a very low temperature rod. We're looking at around 300-degree melting point. The flowing characteristics for this rod are absolutely tremendous. It's a high-strength rod, very high tensile strength. And one of the most important things when using this rod, to remember, do not touch the flame to the flux. You want to heat above it, and you want to heat below it. But do not touch the flame to the flux. If it does become burnt, you might as well stop what you're doing and start over. When we start to see that flux bubbling and turning to a lighter shade of brown, that's just about the right time to add our rod to it. And you can see the way that'll flow in there and absolutely adhere to the aluminum and to the copper or brass. See. Now I do have one that I pre-done with the flux off of it, so you can actually see how clean that the joint does look when you're finished. And that's aluminum and brass. One of the other things that we can do with this rod is attach your brass filler next to your aluminum radiators, your heavy truck stuff, and even your aluminum race car radiators can have brass fittings and brass hose connections on. You want to make sure everything is wire brushed with a stainless steel wire brush. And I went ahead and put a little bit of flux on everything here. And we'll get a little bit on the rod and around the outside here. And once again, most important thing to remember, do not touch the flame to the flux itself. Allow the metal, heat transfer from the metal to melt the rod. bubble and just about go to a slight tint of brown. Right about there. Brass to aluminum. The AccuRod 300 can also be used for aluminum only. Same basic principles apply when you're working with this rod. Stainless steel wire brush. Clean it down to a shiny surface. And I like to pre-flux my work. Keep your heat away from the flux. And we're looking for that bubbling and that right shade of color. About there is the shade. And you can see the way that rod flowed out there. Cover that too. When we just got done demonstrating the aluminum rod for doing our aluminum hose assemblies. Next thing that's going to help you out with your Chrysler steel hose assemblies or transmission lines, power steering lines, would be Brian's red rod. This is a new rod that we have out on the market, and this has your similar properties as does the blue rod. You can use your bench torch with it. It does flow like solder. And the flux is very, very unique and wonderful cleaning properties on this. Here's a sample of our Chrysler hose assembly. And it's going to be a similar way you're going to be doing this. You're going to keep most of your heat on the thicker part of your metal. And again, we're going to be looking for a color change that the flux makes into your metal. A little bit of flux on there, And you can see just right now how it's starting to turn that metal almost a whitish color. And at that point, you're going to want to start working your rod. And you'll see how that just flows out just about like solder. 30,000 psi tensile strength. And about the same properties as our other rod. And you can see how that flows, and just how that cleans that metal right up. With Brian's red rod, we're not limited to just your steels, your stainless steels. It's a bimetal rod. And with this application right here that we're going to do, we're working on a brass filler neck off of a heavy-duty truck radiator. The rod is excellent for like your International S models, repairing cracked tanks, and even on automotive, your GM top inlet hose connections. Excellent rod for flowing out and making sure that it's going to stay in place for you. This particular rod here, or this particular outlet, is a LN9000 outlet. And again, using a bench torch, it allows you to heat your work more evenly. Get a little up to temp. You want to apply just a little bit of flux to that rod. You can see how it's working that metal already. Look at the nice bright colors that it's turning that metal. As soon as you start to see your color change, you want to start with your rod. See how nice that flows out? Using a larger torch with a bigger flame is not necessarily hotter, but it's going to keep your metal warpage down to a minimum. And unlike some other rods, if you do need to go back over it to neaten it up, this particular rod is just wonderful for that. You can just flow it right out. For the neatest looking repair. Just key on that flux. It doesn't have to be 100% clean. It's excellent for working on your used transmission coolers or heavy hydraulic coolers. It helps clean the area. For this particular repair for the red rod, just imagine that this fitting would have been stripped out. I would have pulled that fitting off and taken one off of a good cooler and then put this, set it back in place. And with the red rod, it makes the job a breeze. Keeping your torch moving, make sure everything gets heated up about the same temperature, about the same time. Keeping your metal, keeping your heat on the thickest part of the metal. And watching for that color change. Looking for that flux to change the color of the metal, which is going to be right around there. That time you want to try your rod. The next rod I'd like to go over with you is Brian's Red Rod. This unique 56% silver multi-alloy rod, it works well with stainless steel tanks, also with your steam units, hydraulic oil coolers, anything that's moving. Your 56% silver allows it for flexibility and your different pressures and different temperatures. Today, we're just going to show you the flowing properties of this rod on a stainless steel tank. We'll be doing stainless on stainless and mild steel on stainless. Now, I did clean these up a little bit, but they're not perfect. What we're looking for is basically the same thing in the rest of our rods. You're looking for a color change that the flux makes on the metal. You want to put a little bit of that flux on there. Use your base metal and the piece that you're going to be working on. Like I said, with your bench torch, these rods make the job very easy. Notice the color change when that flux gets up to the right temperature, how it cleans that stainless right up. You see in the center of that, just how that rod penetrated the whole way through that. Now that was stainless on stainless. We're going to try a mild steel on stainless. We're going to try this on a spot of the tank that wasn't clean, just to show how well that flux does work. Just about at that right temperature. See how that turned white? Steady, even temperatures with a medium flame. Penetration and the cleaning factors of this rod is extraordinary with the bench torch. And when you're working with steam units and hydraulic oil coolers, the flexibility is tremendous. It is a very unique rod with a very unique flux on it. It works well at the bench. This particular repair is for our heavy-duty audience. Brian's Red Rod is very, very flexible under extreme pressures and temperature conditions. These particular units are industrial drying units. They're steam, which you're looking at anywhere from 300 to 400 degrees. And on the lower side of the scale, as far as pressure-wise, they're running right around 120 to 150 psi. With a tensile strength of 30,000 psi, this rod is perfect for this application. Using the same procedures we did in our earlier repairs, we can go ahead and make decent repairs to these industrial cooling units. We've made repairs on your Caterpillar oil coolers, your Ingersoll Rand oil coolers out of the bigger sandblasting units and compressor units. It works very well, very well. With the 56% silver, the flexibility and the temperature-wise, this thing expanding and contracting through the weather conditions and heating and cooling conditions in this unit. The rod material remains very flexible. after that color change, it starts the cleaning process. Right at that certain color change, you're going to start adding your rod. See how nice that flows in there. I'd like to demonstrate our AccuRod HD at this time. This is a flux-coated rod. Working temperature is right around 1100 degrees. This is used for your cast aluminums, radiator tanks, heavy-duty radiator tanks, side rails, broken bolt holes, your charge air cooler headers, charge air cooler mounting brackets. Today, what we're going to be working on here are simulated cracks in your bolt holes on your side rails, and I also have a crack on the back side. This particular rod is used with an oxyacetylene rig. And what we're looking for a flame, the type of flame we want to use, is going to be a flame with a slight tail on the end of it. A blue cone in the center, and you want a little bit of a light blue flame around the outside of it. This particular rod, we actually melt your base aluminum. You want to make sure you get it up to temp. And as soon as you start to see your base aluminum melting, I like to flick the old dirty crack out of the way. Just break through it. What this is doing is taking a little bit of flux off of the rod and putting it onto the aluminum and cleaning the surface for you. Once you have the crack out, take your rod and melt it into place. This rod is very malleable as far as it's very forgiving when you're welding. You can, if you get a little too much on, you can flick it off and make it smooth. You can actually shape and build with this rod. It's great for shops that don't have electric welding capabilities. And we're going to go to the next crack too. Now that the side rail's heated up, it's really working nice. See, when you put that crack out there and that flux that's on the existing aluminum, it really cleans it up. At this point, you're looking at the same properties with our other rods. There is a color change in the aluminum when the flux hits it. And you can smooth it and work it with your torch and your rod. Our next repair is going to be on a little bit thinner piece. You can see how nice that turned out. Our next repair is going to be on a simulated crack on this side of the side rail. A much thinner part. As most of you know, when you do heat aluminum, sometimes it likes to disappear on you. One of the tricks to torch welding is keeping your torch flame pointed towards the heaviest part of your tank. And you also notice I didn't do a whole lot of cleaning to this either. This has been laying around the shop for months. You're looking for the same thing that we discussed just a while ago. Preheat your area. And you're going to go right in and V the crack out with the rod and dig with the torch. Dig the whole crack out. And then we want to just go back to where you started and blend the rod in. The rod really works well on cast aluminum. All the dirt floats to the top along the edges of your weld and leaves you with a nice, smooth, leak-free weld. This flux can also be removed with hot water.